Astronomical telescope at normal setting. Astronomical telescope at normal setting, that is astronomical telescope with relaxed eye. This is the principal axis of two lenses. First lens towards the astronomical objects is known as the objective lens. This is the objective lens. And another lens is eyepiece. The other lens is eyepiece. We can draw the real image P prime Q prime, formed by the objective lens in the focal plane of the lens, and from the real image P prime Q prime, and this real image P prime Q prime behaves as virtual object with respect to the eyepiece. And from this virtual object P prime Q prime, two rays, we can denote two rays. One ray will be passing through the optical center of the eyepiece without any deviation. Another ray is traveling parallel to the principal axis. In this case, P prime Q prime, the real image P prime Q prime is formed at the second focus of the objective lens, and it is also formed at the first focus of the eyepiece. Now the ray which is parallel to the principal axis will pass through the second principal focus of eyepiece. That means this refracted ray will pass through the second principal focus F2E of eyepiece. And these two parallel refracted rays will appear to diverge from infinity. So here we can denote two refracted rays which will appear to diverge from infinity. And refracted rays are extended in backward direction by dotted straight line. The refracted rays are extended in backward direction to show that they will appear to diverge from infinity, means the final virtual image P double prime Q double prime will be formed at infinity. And here we can write that this refracted rays which are parallel to each other after refraction through the eyepiece will appear to diverge from infinity. Now we can denote an incident ray. We can denote this is the aperture of the objective lens, and we can denote a ray which is coming from the astronomical object and pass through the optical center O of the objective lens without any deviation. This is the ray which is coming from astronomical objects. We can denote another ray, two rays which will be parallel to the first ray which is passing through the optical center. Here we have shown three rays which are parallel to each other coming from astronomical objects, but not parallel to the principal axis. And these parallel rays coming from astronomical objects will converge to the point P prime Q prime after refraction through the objective lens. The refracted rays which are parallel to each other coming from the astronomical objects will converge to the point P prime Q prime after refraction through the objective lens, and this incident rays coming from the astronomical objects makes an angle alpha with the principal axis of the two lenses, and beta is the angle subtended by the real image P prime Q prime, which is formed in focal plane of the objective lens and which is also formed at the first principal focus of eyepiece. And P prime Q prime behaves as virtual object with respect to eyepiece. That's why object distance UE is equal to FE, and we can denote, we have shown the focal length FE. FE is the distance of the second principal focus F2E from the eyepiece, and also we can denote the image distance of real image P prime Q prime from the objective lens, which is equal, which is V. That means V naught is equal to F naught, and here these are the incident rays from astronomical object. When parallel rays from the astronomical object when parallel rays from the astronomical objects are incident on the objective lens of focal length f(O) of an astronomical telescope at normal setting, comma, the objective lens will form a real image P prime Q prime. The objective lens will form a real image P prime Q prime in the focal plane of the objective lens. That is, at the distance of V0 is equal to F0. Image distance is V0, which is equal to the focal length F0. Also, this real image P prime Q prime is formed at the first principal focus of the eyepiece of focal length Fe. Hence, the eyepiece will form the final virtual image. The eyepiece will form the final virtual image P double prime Q double prime of the virtual object P prime Q prime at infinity. The eyepiece will form the final virtual image P double prime Q double prime at infinity. In this case, real image P prime Q prime behaves as virtual object with respect to the eyepiece. And this eyepiece forms final image at infinity. Therefore, the magnifying power of the astronomical telescope at normal setting is given by capital M equal beta by alpha. Which is equation 1, where beta is the angle subtended by the final image P double prime Q double prime. Beta is the angle subtended by the final image P double prime Q double prime at infinity. If the angle alpha and beta are very small, then alpha approximately equal to tan alpha and beta approximately equal to tan beta. Therefore, the magnifying power capital M is equal to tan beta by tan alpha. M equal to tan beta by tan alpha. From the triangle P prime Q prime OE, tan beta is equal P prime Q prime divided by OE Q prime. Also, from the triangle P prime Q prime O, tan alpha is equal to P prime Q prime divided by O Q prime. Therefore, M equal P prime Q prime divided by OE Q prime whole divided by P prime Q prime divided by O Q prime. Or M equal OE Q prime divided by O Q prime. Therefore, capital M equal V0 by UE. Capital M equal V0 by UE, which is equation 3. Now, the image distance from the objective lens is given by V0 is equal to F0 because the objective lens forms a real image P prime Q prime in its focal plane. Using lens formula for the eyepiece, we get 1 by VE minus 1 by UE equal 1 by FE. under bracket in the second line, using sign convention for the eyepiece, VE tends to minus VE, and the focal length of the eyepiece FE tends to plus FE. Now P prime Q prime is the virtual object with respect to the eyepiece, and we can consider two rays. One ray is passing through the optical center, another ray is parallel to the principal axis. And the final image P double prime Q double prime is formed at infinity, that is at the distance VE equal infinity, as the final image is formed at infinity. Here the ray is traveling towards right, but the object distance of the virtual object UE is measured in the opposite direction. In the second line, we can write 1 by minus VE minus 1 by UE equal 1 by plus FE, or comma, what we can write, 1 by UE will be equal, 1 by UE will be equal minus 1 by FE minus 1 by VE, or comma, 1 by UE is equal minus 1 by FE plus 1 by VE under bracket. 1 by UE equal 1 by FE plus 1 by infinity, since VE equal infinity, as the final image is formed at infinity. As the final image P double prime Q double prime is formed at infinity from the eyepiece, that's why you can say that the image distance of the final image VE is equal to infinity. Therefore 1 by UE equal minus 1 by FE. 1 by UE is equal minus 1 by FE, where UE is the object distance of the virtual object P prime Q prime. Therefore capital M, that is the magnifying power of the astronomical telescope, will be what? Capital M will be equal to FO by minus FE. Capital M equal FO by minus FE, which is the magnifying power of the astronomical telescope. Magnifying power of the astronomical telescope at normal setting. Normal setting means the final image P double prime Q double prime is formed at infinity. That means this telescope is used with relaxed eye. Capital M is equal to minus FO by FE. Now we can denote the distance between the two lenses in astronomical telescope, and that is also the length of astronomical telescope. L is the length of astronomical telescope, which is denoted by both sided arrow, because this length is not an optical distance. Here the length of the astronomical telescope is L equal V naught plus mod UE. Here the image distance of the real image is V naught, which is equal to F naught, and object distance of the virtual object P prime Q prime from eyepiece is UE, which is equal to FE. So finally we get the length of astronomical telescope as L equal FO plus FE, which is the length of astronomical telescope at normal setting. L equal FO plus FE, that is the sum of focal lengths of the two lenses. Another conclusion, that is astronomical telescope. We can compare astronomical telescope on the left hand side, right hand side, astronomical telescope at normal setting. We can compare, that means astronomical telescope, and right hand side astronomical telescope at normal setting. Left hand side, the final image P double prime Q double prime is formed at the least distance of distinct vision. That is at the distance VE equal D from the eyepiece. On the right hand side, the final image P double prime Q double prime is formed at infinity, that is at the distance VE equal infinity. Number 2. Number 2 comparison is M equal has the expression minus FO by FE 1 plus FE by D. That is the magnifying power of astronomical telescope. Magnifying power of the astronomical telescope, which is the maximum magnifying power. M equal minus FO by FE 1 plus FE by D, which is the magnifying power of the astronomical telescope. Astronomical telescope, which is the maximum magnifying power. Right hand side for astronomical telescope at normal setting, magnifying power M is equal to minus FO by FE. M is equal minus FO by FE, which is the magnifying power of the telescope at normal setting. M equal minus FO by FE, which is the magnifying power of the telescope, astronomical telescope at normal setting, that is with the relaxed eye. And this magnifying power is minimum. This magnifying power is minimum. In this case, for astronomical telescope, M is the product of minus FO by FE into 1 plus FE by D. But for astronomical telescope at normal setting, M is only minus MO by ME. So for astronomical telescope, magnifying power is maximum, but for astronomical telescope at normal setting, M is minimum. Now the length of astronomical telescope L is VO plus mod UE. Right hand side for astronomical telescope at normal setting, length L is equal to FO plus FE. On the left hand side, L is equal to FO plus mod UE. But on the right hand side, the length of the astronomical telescope at normal setting L is equal to FO plus FE. FO plus FE. L equal on the right hand side, L equal FO plus FE, which is the length of telescope tube at normal setting, which is the maximum length of the telescope. Right hand side, L is equal to FO plus mod UV, which is the length of telescope, and that is the minimum. That is the minimum length of astronomical telescope. Number 4, the magnifying power. The magnifying power becomes maximum. Right hand side, magnifying power is minimum for normal setting. Magnifying power becomes minimum at normal setting.